All right, so in this video, we're going to take a look at how do you simplify rational expressions. So let's take a look at the first example. So let's say you have 5a cubed b cubed over 15a raised to the power 4 b squared. Okay, so the way you want to simplify this, the best way to go about it is you want to isolate the coefficients and simplify them by themselves, then the A's and then the B's. Okay, so basically bunch them or group them. Okay, so if I isolate the coefficients, I have 5 over 15, which gives me let me write this a little differently. So let me just put a little line out here, and that's going to give me 5 over 15, which is equal to 1 over 3, right? Okay, so the next thing, we got to simplify this. So this becomes a cube over a raised to the power 4. And to simplify that, we need to understand a rule. Okay, it's if you have, let's say, a term a raised to the power m over a raised to the power n, then that can be equal to, that simplifies as, now the important thing is the a's have to be the same. Okay, so that's called the base. So the bases have to be the same, the powers can be different. Okay, so we have a raised to m minus n. Okay, that's how that works out. So in this case, that is going to be equal to a raised to 3 minus 4, which is a raised to negative 1. All right, and then we do the same thing with the b's. Okay, so that becomes b cubed over b squared, which is b raised to 3 minus 2, which is b raised to 1. All right, so now let's put them all together. Okay, so we take the a's, the 5 over 15, what that simplifies to the 1 third. We take the a raised to negative 1, and then we take this. So when we put it together, we get 1 third times a raised to negative 1 times b. Okay, now a raised to negative 1, it's not common to kind of keep this as a negative term. So here's something else that you want to consider. Anything raised to a negative power. So let's say you have a raised to negative m. That can be written as 1 over a raised to positive m. Okay, so you just flip it. You put this number or under 1. Okay, put it under 1, and then you change the sign of the power. Okay, so excuse me. So what this becomes is 1 third, 1 over a raised to 1 times b. So now we can write this out properly. So that's 1 third. We'll just keep the b on top, b, and then the a goes at the bottom, b over a. Okay, so there's your final answer. I hope that makes sense. So after this, we're going to take a look at another type of problem, okay? Which is, again, you still have to simplify it, but we're going to take a look at another type, okay? So this one is actually a binomial. Why binomial? Because you have two different terms, and they're connected with a negative sign. So that whole thing is a binomial expression. That whole binomial expression is divided by 6 minus 4x, which is another binomial expression. So you have a binomial divided by another binomial. So out here, what you want to do is you want to simplify this binomial first, then you want to simplify this, and then you want to cancel out what you can to reduce the expression ultimately. Okay, so let's go ahead and do the top first. How can we simplify the top? So if you notice what's happening in the top, you have 4x squared. That's actually a perfect square. And the 9 is a perfect square too. So we're going to use our rules of difference of squares to simplify this. So the square root of 4x squared is 2x. The square root of 9 is 3. So we're going to do 2x plus 3 times 2x minus 3. So that's what this top simplifies to. The bottom, I'm gonna if I compare the 6 and the negative 4x, I can see that 2 is a common factor, so I'm going to pull the 2 out. So when I pull the 2 out, I'm left behind with 3 minus 2x. Now, when I look at these expressions, I'm like, hold on a second. Maybe I can cancel out. So first of all, what I can cancel out these entire terms, okay, or something like this. But I cannot selectively choose the 2 out here and the 2 inside here. Why? Because this 2 is sitting by itself and this 2 is part of a binomial expression. So you cannot cancel only parts of a binomial expression. If you do need to cancel, it has to be the whole thing, okay? So with that in mind, in order to cancel them, you have to, excuse me, you have to make sure that the expressions match. And as you can see right now, these expressions, none of them match. This, or this, they don't match. So, but if you look at this very carefully, you can see that in these two terms, the signs are just switched. So see, the 3 out here is positive, and that's negative, and then the 2x is positive, and that's negative. So if you could switch the signs of any one of them, then you could cancel it out. So and that's an easy thing to do. What you want to do is you just add a negative sign on top. Okay, if you want to switch the sign out here, add a negative sign outside. If you want to switch the sign out here, add a negative sign down there. So we'll just go ahead and switch the sign out there. So we'll put a negative sign out there. Okay, so let's go ahead and put the negative sign. Keep the first binomial unchanged. And the second binomial, it will switch. So we can keep the terms the same. So we can just go ahead and keep the 2x exactly where it is. We'll just switch the sign, and then we'll switch the sign of the 3, okay? And then 2 times 3 minus 2x. Now in the next step, what we can do is we can just rearrange that. So if you rearrange that, then you have as you can see now these two match, and because they match you can totally cancel them out, okay? And when you do that, you're left behind with negative 2x plus 3 over 2. And that's the final answer. Now, the negative sign out here, that can also be written just beside the expression, 2 times negative 2x plus 3. So then you take this out of parentheses. You don't need to keep it in parentheses, over 2, okay? Notice carefully, the negative is actually sitting in line with that line out there, okay? If you put the negative out here, then you have to put a parenthesis around it because the negative applies to the entire expression, okay? All right, we're going to take a look at one last type of problem before we wrap this video up. So the next problem is 2r plus 3 over r minus 4 times r squared minus 16 over 6r plus 9. Okay, so if you look at the r squared minus 16, that's the difference of squares out here. And what we can do is we can apply the difference of squares formula to this one. And then if you look at the 6r plus 9, we can pull 3 out, right? These two expressions cannot be simplified, so we'll keep them as is. Okay, so that's what we'll do. So you can rewrite this as 2r plus 3 over r minus 4 times, simplify the difference of squares, so that's r minus 4 times r plus 4. And then at the bottom out here, we'll pull a 3 out, which leaves behind 2r plus 3, okay? And now when you do all of this, you can immediately see that the r minus 4 can cancel each other out, and then the 2r plus 3 can cancel out, okay? Which leaves us behind with r plus 4 on top, and at the bottom you only have 3. And that is the ultimate simplified form of this expression, okay? I hope you understood what was going on. Thank you for watching.